let's take a look at the structure of benzene and some of the features within it. So the first thing you may remember from Organic 1 is a resonance pattern that we didn't spend a lot of time talking about, but that's about to change. So when you have this cyclic array of pi bonds in a 6-membered ring, we have a second resonance structure that you can draw. And what we can do is take these pi electrons and move them cyclically to get a second resonance structure. But remember that resonance structures don't actually exist. Benzene isn't going back and forth between these two structures. Instead, what's happening is the 6 pi electrons in the ring are evenly spread among those 6 carbon atoms. So sometimes you'll see benzene drawn slightly differently. It's drawn with a ring in the center. And what this represents is the even distribution of those pi electrons. So this is the resonance hybrid structure. In most cases, I tend to draw benzene as one of these two resonance structures with the pi bonds in place, but just be aware that the true structure has those electrons evenly distributed around the 6 carbons. What this also means is that all 6 carbon-carbon bonds in benzene are equivalent. The bond length of the carbon-carbon bonds in benzene are all 139 picometers. For reference, a carbon-carbon single bond is 153 picometers, carbon-carbon double bond around 134 picometers. So what that means is the carbon-carbon bonds in benzene are somewhere between a single and a double bond, and that makes sense because of the resonance. Remember previously where we took structures with the double bonds and drew p orbital pictures, we can do the same with benzene. So if we take benzene and I'm going to draw it kind of flipped on its side, but every carbon has a pi bond. So that means we can draw a p orbital on every carbon. And we see that every carbon in that ring is completely conjugated. So let's list some of the characteristics of benzene. Okay, an easy one. It's cyclic. Every carbon has a p orbital. Which also means it's completely conjugated. And with every carbon having a p orbital, that means that every carbon here is sp2 hybridized. Well, what do we know about the sp2 hybridization? Atoms that are sp2 are trigonal planar. So if every one of these carbons in the ring is planar, the entire ring is planar. As we saw before, all bonds are equal length. And finally, if you were to count the pi electrons in benzene, each double bond contributes 2. So there's 2, 4, 6. So benzene has 6 pi electrons. And we're going to learn later what this means, but that 6 pi number is known as a Huckel number. The criteria we see here is what makes benzene aromatic. And specifically, when we go to eventually apply this to other compounds, these are the primary things we're looking for. We're going to need the molecule to be cyclic. We're going to need it to be completely conjugated. We're going to need it to be planar. And we're going to need a Huckel number of electrons. Although equal bond length is a characteristic of benzene, it's not a characteristic of all aromatic compounds.